Okay, good morning, Dr. Ang. Right now, I will do the rehearsal of the my FYP presentation. Let me go to my slide first. Yep, this is my slide for my final year project, and the title for my project is the Human Health Diabetes Prediction System using data mining method. Okay, first introduction. Why I will plan to do this kind of to extract the data in the diabetes field is because I noticed that currently right now the situation of the hospital, of the medical industry or any healthcare industry, they don't have focus on one specific diabetes of this prediction. So this time I will just use the data set that I collect from the public, from the outsource. So I will just focus on the diabetes of the categorical table. So why another motive that I want to do this kind of diabetes prediction analysis is because of the early detection of the diabetes is very important to every human to maintain a healthy lifestyle, to maintain a good body health condition. So to prevent later on if they notice that they notice when they have late diabetes already, then that time is considered very serious. They need to inject the insulin or any kind lah to wash their kidney. Yup. So this system is to prevent the situation happen. So the main objective is to enhance the dashboarding, enhance the diabetes prediction, the workflow to help both side lah, the patient side and the hospital management side. Okay, the problem statement is because right now I noticed that a lot of people they didn't care of their health condition, especially when they uh, didn't according to what they need and what they want to their body to maintain a healthy body. Yeah. So this one is a dashboarding, and later on I will show you the result on how I can generate the data analysis. So the methodology is the user should provide some details through the hospital receptionist or seek a doctor for a health check. Then from there, the doctor can get the real situation, the real scenario of the data. So from there, then the back end staff they will use the data to the overall data to provide an accurate prediction based on the live data, see whether it's reliable or is it valuable data for the nation to follow or not. Then the system also provide the recommendation and dashboarding to the users to stay healthy. Yeah, there are techniques and software in my the whole ETL process and the data mining. So the data that I get from is from Kangol, Simply Learn, IEEE Computer Society Press, and UCI dataset. After this, I will get the Jupyter notebook to do all those data cleansing and to find out the suitable, the necessary data that I want to use. Then I will use the Figma to push out the layout of the mobile and the website view. After that, I will use the Power BI to do dashboarding. Of course, there is limitation among the data sets. The first limitation is because the outsourced data or online data, public data, they don't have a very nice managed in the calculation, the tables, the category, the name, and the empty data, like the duplicate data, all those things. Another factor is because of the data itself, right? They are like binary situation. For example, yes or no, one or zero. So this is like kind of very hard to determine whether the data is towards the correct way or is just a number to predict. Yeah, this is the main limitation when I use the data to do like all those correlation, to like sort it out, sorting function, and filter some of the unnecessary data. So this is the system design, the layout of the UX and UI design of the human diabetes report. And this one is the mobile layout. Then this one is the wireframe from the web page. Later on I will show you this. And this one is the using the compute using the Jupyter to draw it out the data. Why Jupyter is because I found it is very useful, very is effective, and especially Python is to those who are like they want to get the output very fast, very effective straight away. Yep, compared to C sharp and Java, C++, all those. Then this one is a use case. We can see the doctor and the staff of the hospital, they can like go through the data, and the patient is the one who view the overall record, like the statistic, like the poster, all those things. And then how it works, this one is the process of where the data we get, then data load into the process, ETL process, then the raw data, then we take the trust data, we classify all those things, we cleanse all those unnecessary data, then we get into the last step, which is data visualization and some machine learning development. Yeah, then this one is a coding part, I will show you later on. Then this one is a Power BI dashboarding and the heuristic expert review. Yeah, the conclusion. The conclusion, I could say that I will go back to the objective of myself. I start from a end-to-end value from the diabetes patient to walk through all the data to get out the dashboarding, to get out the graph, include the posters, how to prevent, what is the symptoms of the diabetes, the early stage. Then the hospital management, maybe they will print out all those statistic reports, then post in the dashboard there inside the hospital. Then the patient, when they pass by, they will see, or the doctor, they will introduce how you can prevent, what are the symptoms of the diabetes, all those things, and the calculations. Yep. Then right now I will bring you to the coding part. So this one is the first data set that I get. So from Kangoo itself, the majority difference between Kangoo and my dataset is, the main difference is dataset from Kangoo is very messy. They input all the unnecessary data. So for my situation, I just need to like specific focus on the diabetic situation. So I just need to remove all those unnecessary data on my situation. So first, I will import all those Python variables like numpy, pandas. Numpy is for the number Python. Pandas is to read the file. Then plotting, matplotlib, matplotlib.pyplot and inline. These three commands here is to get the draft, get the graph of the statistic, all those things. Then Seaborn and OS, same. Okay, from there I read from my user, my name, my OneDrive desktop, and the data.csv. So dot head, this function is to clean up the first five rows. So you can see this is the first five rows of the result. Then for column, print column, then I will get all these column. I can see what are the column in the data set. Then move on to group by as a unique one, which the column that I need. Then I will move on to the shape. Dot shape is the one who give me like I have 508 rows and total rows and the columns. Yup, then this is the whole data set that I have. Then following up with those necessary, I cut down all already. Then the columns that I left is only 50 columns. So you can see previously they have 3,500 plus of columns, but right now I just take 50 columns to shorten the result, the necessary result that I want. Then I will follow up with this command called underscore short, which means they give it the output immediately. So Python, the useful with Python in is like for example typeface underscore metadata is my data, then underscore short. Once I play this, they will should input this, then the output straight away come out already. Yeah, fast, efficient. Unlike those another programming language which need to like write a lot of code, few lines of code, then can get the output. Python is different. Yup. Then continue with all those like mapping, value, change all those things. Then this function here is to rename function to map in different kind of like category table. Then from there I will get the minimum and the maximum value for hemoglobin and hemoglobin 1C. Yup. Then glucose level, then the gender female, then the shape again. Then after I do these things above, I need to get back again to the latest data type is underscore short 2, which means this data is the full final edited data. Do all those like cleansing already. Then from there, I will get the statistic, and this is group age by age group by the disease. Like we have like pre-diabetes type 1 and type 2, and the blue color one is no diabetes. Then this is the calculation. Then this one is group age and by diabetes by histogram box plot. And this one is the name as total cholesterol level, all those things. Okay, you can see no handles with labels found put in legend. Legend here, if you want to input something, then you can input the necessary comments here. But right now I put this plot.legend is because in the future maybe we want to put some legend as a whole. We need to see the whole picture, then we can put the legend. But right now I just put the X label and the title, so it will automatically count by the cholesterol, by the group cholesterol, the total cholesterol used by the diabetes patient. Then follow up by the C peptide, then the fasting blood glucose, all those things. Okay, the following up is all those like graph, statistic, and all those box plot together with all those calculations, table by table, um, to calculate based on the statistic that we have in our current data. Yep, this is all the function. Then we come to the um, prediction analysis. We have four method of the data analyst prediction. The first one is precision. Precision, this one is used to calculate in range. So for example, in range 10 until the 90, then positive, negative, like we have the box positive, negative, true and false, like this. It's the same. Then underscore precision equal to 3 decimal number percentage. So this one is like 0.75, which means my data under this precision call score 75%. Then under recall method 90%. Under the F1 method 96%. So which means the recall function here is the most highest value that this data able to get, and this 90% is considered reliable valuable data source. So then I will then I will use the training example and testing example. Excuse me. Then we move to the next data set. This data set we get it from the IEEE Computer Society Press. So same, we will input all those Python variables. Then from my desktop as well, then this one is the dot head function, dot head 20, which means dot head, which means get the 5 rows, and 20 inside is get the top 20 rows of data. Then this is the shape. This one compared with the previous one is much more easier, much more simple to get, because they only have 5 columns in total. So this is the info. So you can see pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, this diabetes, pre-degree function, age, and the outcomes. So total 9 columns. Very easy. So describe all those calculation, then column with glucose, blood pressure, all those things. Then we come into the fixed size histogram, fixed size 30 by 30. So all those things we can see in a clear picture in one shot. Okay. Then we move to the mean of the data. We need to get the mean, the median of the data, the standard variables, all those things. But here we get the mean. Then the outcomes. So this one is after we get the mean already, then we will get the train set accuracy. So overall you can see over like 78%, 74%, 78%, and 74%, which means this data set is somewhere around above 70% compared to the previous one. So this one I split it out. I use KNN, K-numbers classifier, another prediction analysis to use. So this one, the train data set is 72%. Yeah, they split it out lah, to 72 and 82% and 71%. Then this one is decision tree, another classifier for data analyst to predict. Why we need to do all this like logistic regression, KNN, decision tree, all those recall method is because as a data scientist or a data analyst, we need to have a great result before we bring it out to the public, before we bring out to the like maybe in the future like board of directors or leaders. We need to go through a lot of analyzing method to get the most accurate numbers that we can get. Yeah, this is why the data analyst will do usually. Then the third data set, this one is get from the UCI data set that measure shine prefer one, the previous the proposal during that time. So this one is the same. We got head, got the shape, and described by cow, mean, standard deviation, minimum, 25, the second quarter, mean, third quarter, and the max. Then this one is a graph. We can get all those point plot, all those scatter plot, all those variables. We can get the correlation. Yep, then this one total data, then we split into training data example and the test examples. So from there we do analyze again. Like this one, we score 76%, which is above 70, but I will use the first data set which is achieved 90%, the previous one. Then all those random forest classifier accuracy random forest reach 87%, which is quite high. So this one is the read print the data frame. So this one is the limitation that I bring it up earlier. So you can see they are like yes, no, male, female, and the yes, no, another side is like 1 0 lah. So it's just binary decision I can make. So there are no numbers. Okay, after this I will bring you to the raw data. Okay, from there we can see the first column. The first column usually is a header, age, gender, all those how many, let me see, there are total 17 of headers, different category, and from category we want to take the correlation. For example, column H as a primary, which means the column H is from the column 1. So from there I will calculate for every subsequent table the header. So we can see the correlation. Of course, one is 100%. Why one each? Because each to each as a primary, so is confirmed 100%. Then you can see each compared to gender, each compared to the polyuria, all those things, weakness, itchiness, visual blurring, all those things that the diabetes patient may face. Then after that, I will use the last column, which is the class, the final class as a primary. So you can see the class is as 100%. Then compare with age, gender, polyuria, all those things. Yep. After that, I will show you the this one. Okay, this Figma, I use Figma to plot out all those layout. For example, this one is for the doctors and the hospital staff, back end staff, the technical one to do. So we can see about us, what we are doing, then the overall data set. This one straight away pull from the Python data set. Then this one is the back button, the report of the age, then report of the fasting details, all those things, because doctor they need to see the quick result. They straight away based on the graph they know the result already. Then the prediction analysis, then they can see under precision got 75%, under recall method got 90%, under F measure got 76%. Then the test train data, how many data we have to compare. Yep, this is for the doctor's usage, and the web is for the patient side. So we can go to about. About is to study the human diabetes prediction, and one of the system in hospital management, see whether the insulin intake whether it's good or not. Then overall statistic, same. This statistic also get from the Python, the output. Then go back to home. Then report related to age. This one is a report histogram, and this one is actually box plot to know diabetes, pre-diabetes, and type 2 diabetes. So maybe in the future the hospital, when they need to like print this out, then they can print it in the hospital board, like the pass by passenger or the pass by patient, or easier for the doctors to introduce what is diabetes, to get the insight of the diabetes. Then blood glucose fasting, so can scroll down insulin fasting, then we can get the box plot of it. Then related to cholesterol, same. Then types of diabetes, from here we can see type 1, type 2, and the gestational diabetes, like all those, because not everybody they are able to input the inject the insulin. They need to base on which type they are, then the hospital, they know whether need to assign the insulin to this patient or not. Then the diabetes symptoms, you can see all those like always hungry, thirsty, like headache, pain, frequently go to washrooms. This is for the patient use, and the mobile layout is for the doctors who use. So after this, I will go to the Power BI dashboard. In this Power BI dashboard, so make it clearer. Okay, this one. This Power BI dashboard I use because Power BI, why I use Power BI is because it's easier to extract the data. But before extract the data, we need to do all those like data cleansing, data sorting function to get the real data that we want. Like for example, this one is count of BMI and count of age from the abundance data. And from this data, we get age, then we count these things. The difference between count and count these things is count these things, they will remove all those duplicates, and count they will just straight away count. Then we can see all those count of death, count of age range, antivirus, all those. And this cholesterol table here is a slicer. So 7 point 4.7, 7.81. Then according to this slicer, then all the data will be changed, because this one is Power BI. I set all the filters as integratable interaction lah. Then statistic page. This one this one is just the information page to get a real situation what's going on. And statistic page is more deep inside to get the total data set on set that we have. And this one is the card, and this one is a graph, all those things. Then my diabetes report. This one also including the pregnancy of the sizer, the blood pressure, the age, the BMI, then calculate the two pregnancy age and diabetes, pre-degree function, all those in one. And we go to the pot, and you can see once I click this, beside the box we have all those like glucose, insulin, age, blood pressure. This is because we input the list of the from our data. For example, once we move to this 70, so we can see the clear image. What's the calculation of glucose, insulin, and age, blood pressure, BMI, all those things. Easier for us. And this is the calculation with value input. Yep, this is the all overall dashboarding that I do until right now. This is what I need to present during my presentation time. Yep, let me go back to the page, and I will go back to my slides. Yeah, this is overall that I prepare for my final year project to bring out the situation of diabetes, to get the person to prevent what's going on, everything. Yep, then right now I will end my presentation here. Thank you.